this lesson we're going to be talking about solving quadratic equations again. The only difference is yesterday we had quadratic equations where we just had x squared plus bx plus c. Now we're going to have a coefficient other than 1 for our squared term. So it's going to be similar to yesterday, it's just going to be a little bit more complicated. So for a warm-up, let's remember how to factor a normal binomial or trinomial. We factor it down into two binomials. And notice the coefficient here is 1, and that's going to be the difference today. Since both my middle term and my last term are positive, I know I'm going to have two binomials with adding inside of them. And now I need to find a set of factors of 9 that add to 10 and multiply to get 9. Well, factors of 9, we've got 1 and 9 and 3 and 3. 3 plus 3 is 6, 1 plus 9 is 10. So I'm going to choose 1 and 9 because 1 plus 9 is 10. And 1 times 9 gives me the 9. And that's how you factor a trinomial into two binomials. Today, though, we're going to be factoring where we have a coefficient other than 1 for the squared term. And so when we're factoring trinomials into this form, we're going to find two integers, m and p, with the sum of b and a product of ac. This is the only difference so far from yesterday. Okay? Yesterday's lesson, we wanted to find a factor of c. Now we want to find a factor of a times c. Okay, that's the difference. And then we're going to rewrite this as ax squared plus mx plus px plus c. Okay, so we're going to rewrite it out like this. And then we're going to factor by grouping. Remember, you factor by grouping your first two together and your second two together. Okay, and then hopefully it'll make sense from there. I'm also going to show you another way you can try to do this, but this way involves a little less guess and check. So here we've got 5x squared minus 13x plus 6. And then we're going to find m is negative 10 and p is negative 3 because we need to have numbers that add to negative 13. And then they need to add to bb, which is negative 13. Then they need to multiply together to be the product of a times c, which would be 30. 5 times 6 gives me 30. And notice, negative 10 times negative 3 gives me 30. Negative 10 plus negative 3 gives me negative 13. And then they factor by grouping. We've got the first two terms. We can take out a 5x, and we're left with an x minus 2 in parentheses. Plus the second two terms, we factor out a negative 3, and we have x minus 2. And then remember our rule. If we have the same thing in both parentheses, we can simplify it by writing what's in front of our first parentheses plus or minus what's in front of our second parentheses times what's in our parentheses. Okay? So 5x minus 2 minus 13x plus 6 would factor down to the quantity of 5x minus 3 times the quantity of x minus 2. This is probably the easier way to do it. Okay? Another way you can try to do this is say, okay, my middle term is negative, my last term is positive. So I know I'm going to have two terms with negative signs in them. However, what makes this hard is that you've got to guess and check a lot more. So this part down here would be like doing it how we did yesterday. However, I'm going to advise you to just try to do this new method where you rewrite the middle term out as two separate terms and then factor by grouping. This way is much easier, okay? And it takes a lot of the guessing out of it. And you may be wondering, well, what if I would put negative 3x first and negative 10x second? The order you put these in doesn't matter. If you switch the order of these two terms in the middle, all it would do is switch your answer around so you have x minus 2 times the quantity of 5x minus 3. But remember, that's the exact same thing because of the commutative property of multiplication. So the big thing here is whenever the number in front of your squared term is something other than 1, we have to factor a different way. So let's look at a couple different examples. We're going to factor each trinomial. Okay, so we've got 7x squared plus 29x minus or plus 4. Notice the number in front of x squared is 7. It's something other than 1, which means I'm going to use this new method we're talking about. So we know we have to add to BRB, which is 29. So whatever we get for m and p have to add to be this middle number. Then they've got to multiply to be whatever a times c is. Remember, a times c, 7 times 4, gives me 28. So we need to find a set of numbers that add to be 29, multiply to be 28. And since both these terms are positive, we know we're going to have positive terms. Okay, hopefully it becomes pretty easy to see that it's 1 and 28. Okay, because 1 plus 28 is 29. 1 times 28 gives me the 28 I want. So now we've got 7x squared plus 29x plus 4. We're going to rewrite that as 7x squared plus m times x plus p times x. Here's our m, here's our p. And again, doesn't matter which order you put them in. Okay, I'm going to put just them in the order we have them written. 1x plus 28x. All I did was I broke apart this middle term, so I had it as factors that added together to be the 29, but then multiplied together to give me whatever I get when I multiply the first coefficient times my constant. Okay, a times c, which is 28, plus the 4 at the end. Now we're going to factor by grouping. So I'm going to group the first two together. I can see I can factor out an x. So I get x times a quantity of 7x plus 1. Then I'm going to factor the second set plus, I can see I have a common factor of 4, and I get 7x plus 1. Okay? Now that I see I have the same thing in parentheses, I can just rewrite it as adding together the two things I'm multiplying together. X plus 4 times the quantity of 7x plus 1. And there's your answer. It's factored. So a little different than what we did yesterday, but hopefully not too complicated. Okay? The big idea here is splitting apart these middle terms, this middle term, and then factoring by grouping. Okay? And remember, had you mixed up the 28 and the 1, you would have gotten this exact same answer. You just would have switched around the 7x plus 1 and the x plus 4, which is absolutely fine. Now the second part, okay, it looks pretty complicated, but notice I actually have a common factor for each of these numbers. So I could rewrite this as 3 times the quantity of x squared plus 5x plus 6. Because you see the greatest common factor of 3 with all those terms. And now, looking in here, you can see that this is actually like a problem we did in the previous lesson, where we have the coefficient of 1 in front of the squared term. So now I can break it down into two binomials. I've got two pluses, which means both my binomials will be adding. Now I need to find numbers that add together to be 5, multiply together to be 6. Well, 2 plus 3 is 5. 2 times 3 is 6. So this actually ends up being 3 times the quantity of x plus 2 times the quantity of x plus 3. Finding this GCF is really going to make some problems easy. Okay? Because if you try to do a problem like this, like we did in part A, it actually would be very difficult to do. You'd have to do it a little differently. So always check when you have a trinomial, see if there's a GCF. Here we had a GCF of 3. So we factored out that GCF before we started doing it, and it actually ended up making our problem much easier because it turned into a trinomial without a leading coefficient other than 1, which meant we could just factor it the way we had done in the previous lesson.